Hello, everybody, and welcome to PyData Global 2024. We're very thankful that you are here with us today, joining from all around the world. So good morning, good afternoon, good evening, wherever you are. I am extremely thankful for our speaker here today to spend time with us and energy into this tutorial. Suji, we're thankful that you're here. Everybody, please, this is a 90-minute session, and those are can be really, really fun and interactive if you are using the chat features, using the question and answer bubble that should be right on the right side of your screen. Interact, ask questions, talk to each other, and have a lot of fun in this data prep kit workshop. Suji, thank you again. The floor is all yours.
Thank you, Tamara. Welcome, everyone. I know people are trickling in. So one thing you can do right now, actually, let me take my picture off so you can take a picture of this. There you go, right? So you could take a picture of this slide, and I have a link right here where I'm pointing, yeah. So that's pretty much all you guys need, right? Everything we need in this is in this link. So if you want to take a second, go ahead and take a picture, record the link. That's all you need. Yep. Everything else will be on the link. I'm going to give like a few seconds for people to trickle in, and then we are going to start soon. Yeah. Let's see this. Okay, yeah, let's try this. So this way you can see me. And yeah, go ahead and take a picture. And also, if you look at the resource section, which you guys are familiar, on your Air Meet, which should be on your right-hand side, the links are there. Right. Okay, so let's get started. Very quickly, quick intro. My name is Suji Maniyam. My background is AI, data engineering, and lately more Gen AI side of things. I do consulting and training in this space. Links and emails are here. Feel free to email me. I love hearing from you. If you have any questions, feedback, whatever, right? So you can email me right here. Yeah. So, and again, all these links are right here. You can take a picture of this. So what we're going to do today, right? This workshop, we have for 90 minutes. But I don't want to take up all 90 minutes because what I want to do is I want to walk you through a toolkit. It's going to be hands-on, right? You can do this along with me, and I'm going to give you some time back so you can kind of practice and finish this on your own. Yeah, sounds good. And we are keeping you guys on mute so the line is clear. However, if you have any questions, please put them on the chat window. This way, right? I will see it. Let me make sure we have a chat window open here. And on this way, you can ask questions anytime, and feel free to ask questions anytime, please, because there's no such thing as too simple a question, because when you ask questions, everybody learns, right? So it's going to be fun. It's going to be interactive, right? Because we want you guys to do a hands-on workshop. I have a couple of questions here. Let me just check the window real quick. Right, where's the code? Yeah, so let me show you where the code is at. Right. Now, if you can see this link, right? This link is where we are going to go. Go ahead and click on this link, or if you scan with your phone, right? You can type it in, right? It's a simple bit.ly link. Let me put this link in our chat windows also. Just just so you're aware. Yeah. All right. So we click on this link, it should take you to this GitHub page. All right. It's larger. And this one has all the resources, everything you need to run this function. Okay. So is everybody kind of clear where things are, right? Again, everything's in this link, right? Once you click on it. Yeah. So let me show you a little bit about this data prep kit. So the data prep kit is basically a toolkit to help you clean and prepare data for your machine learning AI applications. I'm going to show you a very quick overview of the toolkit. So again, right, like I guess, all the links are right here on the slide, right? You can actually follow along. By the way, if you're wondering where the slides are, right, if you scroll down a bit, you see all the slides, right? So you can download the slides. They are linked here, and they are Google Slides. You can access them publicly. So yeah, no need to take notes. Everything's you can download everything. Yeah. So again, we have the slides. So once you click on this link, right, the one we actually gave you, back, right, this link will take you to this GitHub page, and everything you need is here. And then if you scroll down a bit, you see the slides, and the code is also, as you can see, is here. Right? Yeah. So don't worry about the code for now. I will walk you through the code a little later. Okay. So what is the data prep kit and why we care? Let me give you a quick overview. So imagine you are writing, let's say you're writing machine learning applications or LLM applications. Maybe you are training your LLMs, fine tuning, right, or doing like a RAG, right, RAG pipeline. Either way, you're going to depending on the data, right? And the data can be pretty diverse. It can be, let me see, and the data can be, for example, you put documents like PDFs, Word documents, HTML documents, right, what have you. Or you could have your data in code. And we cannot just take the raw data and give it to the LLMs, right? We need to actually shape the data, clean the data in a way they understand it. Now, this is a pretty common set of tasks. Everybody does it. Like, for example, let's say I have a bunch of documents I want to process. So first thing I may want to do is I may want to dedupe the documentation, right? Because let's say I have 1,000 documents and 100 of them are duplicates. We want to eliminate them. All right. Let's say I have some PDF documents. I want to maybe extract text data out of the PDF. Yeah. And let's say I have some HTML documents. I want to remove all the markups, like headings, highlights, and things like this, right? Because they probably are not important in our sense. So all of these things are pretty common tasks we have to do. All right. Let's say I have code as my input. Same thing, right? We have similar steps we have to do. Like, for example, we want to figure out what kind of a language it is, like Python, Java, C++. We want to figure out if the code has any virus in it. Yeah. So all of these things are very common tasks. And what this data prep kit I'm going to show you will enable you to do is do this common task very easily and effectively. All right. Because let's be honest, even though data cleanup is important, not many of us enjoy the data cleanup. Right? It's kind of boring, right? It's not very exciting, right? But we have to do it. So that's where the toolkit comes into play. So I like to think of the toolkit as like a little Swiss Army knife, right? That has all these little tools built in, so you can just use them, right? Like imagine you're going hiking or camping, right? You carry one of these things with you, right? So they can come in handy in many circumstances. Same idea, right? So a lot of these features I'll explain. Like for example, right? Let's say you want to extract data from PDFs. There's a module for that, right? You want to perform deduplication. Yeah, there's a module built in, right? So all of these things are already built in, so we don't have to spend time writing. This toolkit is open source, right? Right? I'm a big fan of open source. I try to use open source as much as possible. The toolkit is actually open source, right? It can handle both documents and code, which is great. So depending on your input, whether you have like PDFs, Word documents, right, or you have code, whatever your input data is, it can handle both. And it's in Python, right? So it's very easy to use, right? And you will see when you run our labs. Yeah. So let me show you a very high-level overview of what are some of the functionalities available, right? So first thing is, it will basically, for example, extract PDF documents or your HTML documents. We want to process them. We want to extract the actual plain text in the documents, right? There's a module for that, right? We can do. So that's where you would probably start. Let's say you're analyzing some documents. This is probably the first step, right? So text extraction built in, yeah. So I want to show you another cool feature. It's called deduplicating. So let's say I have documents A, B, right? So you can see these two A's are the same, right? They're duplicates. These B's are almost the same, not exactly, right? We call them near duplicates. Yeah. So there's a feature built in, right? One is called exact deduplication. It'll look at the documents and it'll eliminate one of the duplicates. Right. So for example, let's say I have just two documents, A and A, right? They're exactly the same. I run it through dedupe. I am only left with one A, right? So one A has been eliminated. Right. And this you want to do this because when you're preparing data for machine learning workloads, you do not want duplicate data. Very important, right? Because duplicate data will mess up. A, it adds to your workload, right? And B, it also affects the model quality. So we don't want that. Yeah. So as you can see, right, we run through the dedupe. I'm left with one document. Cool. Yeah. Now this is a kind of a cool feature. It's called fuzzy dedupe. So the previous one I just showed you is called exact, right? Because these documents are exactly the same. We removed one, right? Easy enough, right? But what if the documents are nearly identical? Like, so look at B and B dash. So look at, I just put a sentence just to give you an idea, right? So let's say, right, Earth is the third planet from the sun, and the other one says our Earth is the third planet from the sun. And almost the same, just one word difference. So imagine, you have documents, exact same documents. Maybe one has like an extra new line, right, or extra period, something, right? So they're not exact, but they're almost the same. And if you have, if you run through fuzzy dedupe, right, it'll basically keep one. So this is kind of nice because this is not something you see more, all that much, but it can come in pretty handy because we will have documents. For example, let's say now we have two documents. The only difference is like there's like an extra new line. Right? Easy to eliminate. So, pretty cool, right? So just to kind of wrap up deduping. So remember, I started 4 documents, right? 2 exact duplicates, 2 near duplicates. I run through the dedupe process. Right? The first one eliminates the exact dedupe, right? A is disappeared. Then, right, the fuzzy dedupe can also catch the near duplicates and eliminate these. Pretty good, right? So I'm ending up with 2 clean documents. So, guys, feel free to ask questions anytime. You can post them on the chat window, right? I'll keep an eye out. If you have any questions, please ask them anytime. So remember I said removing markups. Like for example, let's say I have some document that has like some formatting, some color coding, things like this. They are probably not important for my workflow. So I can run the markup remover. It'll actually eliminate all the markups. So I just get plain text. Pretty good, right? Chunking. Chunking is important. I'll talk a little bit more on this one. So chunking is basically splitting the documents into pieces. Right? Why? Because we actually want to query our documents, and we don't want to query the entire document, right? Because search is more efficient when you have chunks. And chunking has different mechanisms, like you can do like page by page, paragraph by paragraph, whichever one you just like. And here I'm showing a scheme that's going like paragraph by paragraph, right? You can see like each paragraph, right? Let me see kind of here, right? So this kind of becomes, right, this chunk, right? This paragraph becomes this chunk. You can see it, right? So anyway, yeah. Also, another cool thing the toolkit has is removing personal information. So let's say you are, processing some customer support tickets, right? And one of the customer may have accidentally left some sensitive information, like they say, "Oh, my phone number is this, my social security number is this, my credit card number is this," whatever, right? And they left some sensitive information. We want to remove these before we can train our models. Right? So it's called PII, personally identifiable information. So things like credit card numbers, social security numbers, things like this, the toolkit can remove it for you. So we're kind of so hopefully this should give you an idea. You're like, oh, okay, I have a use case like this. Take a look at the toolkit, right? It's very easy to use. Another thing is we can see it's called language identification. Like, for example, you have mix of documents, some in English, say some in Spanish, right? Some in Japanese, perhaps. You want to tag the documents. So you want to identify which language that is. Again, the kit has a feature to do this for you, right? So you can say, okay, doc 1 is English, right? Doc 2 is Spanish, doc 3 is Japanese. And then you can choose to say, what, I only want to process English documents, or I only want to process Japanese documents, right? Because the toolkit can actually identify the language for you. Pretty good, right? So, also, when I talk about languages, the previous one is spoken language, right? English, Spanish. Right? You can also do the same thing for programming languages. Right? Let's say your input is code, and you want to basically segment the code by language. Yes, right? You can say, right? You can identify what the language it is. Right? Also, when you're looking at code, it also has a feature to show you if the code has a virus. So you can scan the code and remove any virus files, right? Which is important because you don't want to train your model with virus code, right? So yeah, so you can scan the code and then figure out if the virus is present. Okay, you can flag the code. And then finally, embeddings. I'll talk about this a little later, so I'm going to skip this because we'll come back to this when you do the workshop, right? So I sort of walked you through some of the features that Prep Kit actually has. So we talk about things like extracting text from PDF documents and HTML documents, or processing code, right? And then I talked about things like deduplication, programming language detection, and all this stuff, right? So there are a lot of features, right? I highlighted some of the big ones, but there are tons of features it actually has. So the idea here is you have a easy-to-use toolkit that can help you with some of the most common tasks that you will encounter. Yeah, so how easy it is to use? Remember, it's in Python, right? So Python, you're in luck. So it's designed to start on a laptop. So you can start with your laptop. If you have small set of documents, that's all you need. But once your document set gets larger, right, a single laptop may not be able to handle it. So you can scale this into like Ray or Spark, right? These are very common, very popular frameworks for distributed computing, right? They will take your code and then run them on multiple machines. So you can see it here, right? So my code now runs on 3 machines. So if you have lots of documents, hundreds of thousands or millions of documents, this is how you would process, right? You will process them in a distributed fashion, running on a cluster. And the toolkit is actually designed to scale to a large number of machines, which is pretty cool. So this toolkit, by the way, is used internally in IBM. So IBM has a model called Granite. It's an open source model. They released it as an open model. This toolkit is actually used to prepare data that to train Granite, right? So for the Granite workload was like multiple terabytes of data running on thousands of machines. So this is actually a pretty proven technology. It's not some new thing that's untested. This is actually very well tested with the real world scenarios. So anyway, just to give you an idea, right? So check it out. This is a URL. If you search for data prep kit, you will find it. It's on GitHub. It's open source. What we are going to do next, we are going to actually do like a little see the features. You sort of have have an idea of the features. Next step, we're actually going to run through the features on our own. Right? So you actually see it in action. All right. Okay, let me pause a second real quick. Let me see. I have a couple of questions. Let me take those. So one of the question is approaching like NLP text searching, right? So if we have just a free form text, and let's say you want to feed the data into like a large language models, you may want to use a technique called chunking. Yeah, right. So what chunking does, right? It actually splits the text. Let me go back here. Yeah, into right more meaningful segments. Then right, each chunk can be a row for you, and then you can feed these chunks into LLM. Right? So if your document is quite large, let's say you have a 100-page document, right? You may not want to send the entire document to LLM because right, because your answer may be in one paragraph, right, or one or two paragraphs. You only want to extract the paragraphs and then send it to the LLM, right? So which you can actually look at an answer. So how do you do that? So the way you would do that, just to kind of give you an idea, go here. Let me just draw here. So let's say you have a bunch of documents, you have a bunch of chunks. You'll basically put them into a like a vector database, right? And then when you do a query, you query the vector database. So let's say I had 1,000 chunks, right? Let's say I'm asking a query. So the chunks, remember, chunks are just, let's say, for the simplest use case is paragraphs, right? Let's say I'm asking a question. So let's say I have 1,000 chunks available, but my answer, the question is only maybe only on 3 paragraphs. So when I ask a question, the vector database is going to give me the 3 relevant paragraphs. So this is the one I send to LLM, and then I get the answer back. Does that kind of make sense, guys? Yeah, especially, right? So yeah, so if you want to selectively extract data, you can use a vector database in the picture. So this is a typical RAG application. So we don't want to send all 1,000 chunks to LLM because that can be expensive, right? We only want to send what we call relevant chunks to LLM. Now the LLM can process them and answer your questions. So hopefully that explains this for you. Yeah. Ask me, right? If you have any questions, please ask. Great question, actually. Yeah. Good, guys. Very good. Okay. Let me see. Oh yeah, the toolkit is actually Python, right? So yeah, let me show you here, right? So that's on GitHub, right? The GitHub example page you're looking at is my page I created for this workshop. It should have a link to the actual data prep kit, right? And you can go see, right? Right. Yep, so it's a data prep. Yeah, it's on GitHub. It's open source. Yeah, you can check it out. Very good, guys. Let me see any other questions. Okay, so next up, what we're going to do, we're going to actually do a hands-on portion. So we're actually going to test this toolkit. So, I'm going to part 2. I'm going to bring up this presentation here. Right. So again, if you're following along on GitHub, by the way, just to level set, you can run the code on Google Colab or also locally, right? And if you look at our page, right? I walk you through the getting ready, right, page. So if you go to the getting ready page, it'll show you how to set up your environment. And even though you can run on Google Colab, I would highly recommend you can set up your own Python environment. And the way I like to do this typically is, I use Anaconda or Conda Forge, right? Whichever one you guys like to do. I like to create a separate environment. All right, let me show you something from my laptop here. All right, so let me bring up my terminal here. All right, so this is my laptop, and if I say Conda and list, you'll see I have a lot of environments set up, right? So basically, so for example, you can see, right, I have one I just set up yesterday, that is using version 22, right? But using Python 3.12, right? So I like to have separate environments. So when I install packages, they don't, right? They are contained. So they don't pollute your own workspace. So, and this is the best practice, right? I recommend for every project you guys do, you should create your own environment, right? So instructions are basically here, right? So basically, you can still see, you click on the set up Python environment, right? I'm walking you through, how to create the environments, right? So contact create. So again, right? And then I can even specify the Python version. Yeah. And then basically, once you have the environment, basically, we are going to install the requirement.txt. And that will install everything you need for our workshop. Anyway, so again, we are not going to do this right now, right? I'll give you some time towards the end to do this. Right now, we are going to run the examples on Google Colab. So this way, there's no setup needed. All right, so we're going to keep going. Next option I want to do, let's do a feature walkthrough, and this way you can also do a hands-on workshop. So, I'll skip all this. We covered all this stuff. Yeah. So what I want to do, and here's where the hands-on version is coming in. You want to take a picture of this, or right, or go to the URL. It'll take you to the same GitHub page. We are going to try this. We are going to try it out and see how it performs. Right. So leave it up for a second, so you guys can actually, right. Also, if you look at the chat window, I put the link here as well, so you can come to the link. Yeah. So what I want to do, I want to showcase a use case where I am processing PDF documents. So I'm going to show you, right? So I'm going to show you how to extract text from PDF, how to do chunking, how to perform dedupe and all that. Right? So the entire pipeline we are going to show you. So this is the workflow I'm going to illustrate. So what I'm going to do, we're going to start with a bunch of PDFs. Right? We're going to first extract the text data out of it. We're going to split them into chunks. Right? And then we are going to do like some dedupe. Right? And then finally, we are going to create embeddings for them. So the idea here is you can bring your own PDFs, right? If you have some PDF you want to try out, let's say you have some papers or you have some documents, you can just drop them, right? Bring them in and then use them, right? Easy. So the code is written in a way you can process a PDF from a directory. So just drop your PDFs into the directory, and right, you can get going. Right. So what we're going to do first, right? I hope everybody's at this, right? Let me go back here, right? At the workshop page. Again, this is the page that's in the link, right? bit.ly TPK workshop 2, right? And you scroll down. Okay. This is the this is our agenda we are working through. So I just went through the first two presentations. We are doing the feature walkthrough. So for this, we are going to run the code together. Yeah. So do this for me, guys. So if you can look at my screen for a second, right? We're going to run this code. Let's do option 1. So this is actually running this code from my own repo. So this way you can run the latest code. And you're going to run this on Colab. Okay, how do we do this? Very simple. What I want you to do, right-click on this one, right? Again, we are doing option 1. Right-click, and then say open a new tab. Go ahead and do that for me. Right. So right-click here, open a new tab. And this should open the file in your Google Colab. Right? Let's do that. See how it's loading it, right? Can you guys give me a thumbs up if you're able to load this file on your Google Colab? You need to have a Google account. I'm assuming most of you have it, right? Can you just give me a thumbs up if you're able to open this file? Yeah. Okay, good, very good. So again, what we are doing, guys, is right here. So here's the link, right? Follow the link. I scroll down a bit to the agenda, the code section. We are doing this right now. Right? So simply right-click on the Colab and open a new tab. All right, everyone's good? Okay. And once the code is open, just to save some time, what I'm going to do, right? And I'll walk you through this, but just to save some time, I want you guys to do runtime. I click on runtime and click run all. Go ahead and do that for me. We'll walk you through step by step, but there are certain steps that will take some time, so I want to get them started. Right? So if you're there, runtime, run all. Yeah, that's fine. Yeah. So again, we're doing runtime, run all. Again, at this point, this doesn't need any setup on your laptop, right? Everything's running in the cloud. So yeah, just click on the link and then say run all. Right? So to start running, right? And I'll explain what's going on as we go. All right. So you see like it's running, right? So, all right, how's everyone doing so far? Good. Any questions? Now, the chat window real quick. Okay. All right. Very good. So again, so we understand the workflow, right? We are starting with PDF documents, going through the pipeline, right? So I'll explain a few things. For the interest of this notebook, I chosen like very simple PDFs, just so we can actually understand, right? So you can look at the PDFs here. One is like Earthward PDF, right? Right. So I just kept them very simple so we can actually see what's happening, right? So just a couple of paragraphs, one pager, same thing. Like you can click on master PDF, right? Same thing, right? Two very simple PDFs. What I'm going to do, I'm going to walk you through step by step and show you how to use the toolkit. Right? Okay. So first thing I do here is I'm trying to figure out if I am running on Google Colab or not. Because if I'm running on Colab, I need to do things slightly differently. For example, I need to download files I need, right? I need to install Python packages I need. You remember, Colab gives you a clean environment for every notebook. So every notebook I need to make sure, right, I'm doing, right, I'm doing the setup. And this little test, again, I've been using this, it's pretty effective. It'll tell me, yep, I'm running in Colab. So good, right? So if I'm running in Colab, you can see I'm downloading my data, right? Again, either to a PDF, master PDF, right? I'm downloading these. Remember, because Colab doesn't have these local, right? So I'm going to download them. Okay, that's what. So step 2.2 is just downloading the data, right? And 2.3, this is what's going to take a long time, most of the time, because we have to install our dependencies, right? So you can see, right? Again, I'm only doing this if I'm running on Google Colab. Because if I'm running locally, I don't need to do the install every single time, because I do the install one time and that's it, right? And we are installing version 22 now, 0.22, right? So, and it'll take some time to download and install, right? And is everybody is it kind of doing this still, right? Yeah, it'll take some time to download a bunch of files, bunch of modules to install. So let it run. That's why I actually started this, right? The install process right away, right? Because otherwise we'll be waiting too long. All right, so if it's taking like a couple of minutes, that's okay, right? Just let it run. Yeah, and again, it'll continue running, right? So you're gonna let it run. I'm gonna explain what's going on in our, right now in our toolkit. Again, guys, feel free to post any questions. Oh, great question. So one of the question I have is, how about can it do OCR processing, right? Kind of paraphrasing your question. Um, right. So the PDF processor here we have, excuse me, can actually do OCR. We're actually using a model to a machine learning model to process PDF, which is pretty great, right? The model is called Dockling. I'll actually give you an example here. What's this? Yeah, it's called Dockling. I'll put this link here for you. All right. And, so Dockling is an open source package. That's what we are using to extract data from PDF. It's actually pretty powerful. It can do OCR. You can extract data from tables if you have it, right? Because this actually uses a deep learning model that's been trained on so many PDFs, so it understands how to extract it from PDFs, which is pretty cool, right? So it can actually do OCR, right? It's one of the features. OCR, there you go, right? So if you have like a PDF that is scanned, like let's say you scan some receipt or you scan some invoice, you should be able to extract data from OCR. Right? Now, OCR is never perfect, right? It's never, right? Never 100%, but it can do a pretty good job. Anyway, so even though we are using the Dockling package, we should be able to do OCR on your PDF. Yeah. So give it a try, and yeah, right. If it works, great. Right. All right. Where's my code? Yeah. Okay. Good. Very good question. So guys, please ask ask questions, right? We always love on. Everybody learns from this. Yeah. Okay. So where am I right now? Okay, there we go. So my install is done. There we go. Okay, almost done. Right, still spinning. It's okay. We can just we don't have to we don't need to restart. We can just let it go. Right. Just I'm just going to cancel out of this. Right. Okay. So it'll keep going. Right? So step 2, I'm doing config. Yeah. So basically, right, I am configuring my things. For example, where's my input directory, right? And where's what's the model I'm going to use to do embedding, right? So the basic stuff is actually configured right here. Right? So I'll come back and explain this a little bit. So all we are doing in 2.2 here, right, is basically setting up input directories. Remember, right, I'm starting with an input, and it's going to go through multiple stages, right, as we process the PDF. So the first stage is, we're extracting text from PDF. Right, next, right, I'm creating chunks. Then I'm creating like duplicates. Right? I'm sorry, eliminating duplicates, not creating duplicates, eliminate duplicates, right? Things. So you can see it's kind of going through 0, 1, 2, 3 in the order. Yeah. So all we are doing here is we are setting up workflow directory. Right? Yeah. And I'm clearing the output directory because right, every run I want to do, I want a clean run. Okay. So let's look at step 3 here. It's called PDF to Parquet. This is a very important step. This is a step that extracts the data from PDF documents into text format. Let me show you what it looks like. Okay. Yeah. Just kind of visually, let's illustrate, right? So remember, I started with these 2 PDFs, PDF and master PDF, right? So what we are going to do, and this is, it has headings and things like this, right? So we're going to extract data out of this. And again, like I said, we are using a model called Dockling to do the work, right, behind the scenes. So you can see extraction. You look at the PDF, we'll start extracting the structure, right? You can see, right, here's a heading. See how the heading is, right? It says Texas Solar System subtitle level 1. So it's a level 1 heading, right? Next paragraph, you can see the one in the green, it becomes another, right, another section. You can see, right? When you can see type paragraph. So this is kind of pretty cool because you can see it's actually extracting text while keeping the structure intact, right? And you can see like, the list item, right? Right, it's list item. Pretty cool, right? So it started extracting data from the document. So that's what the first step is doing, Right? So let me look at the code again. I'll also switch back and forth between the presentation and the code. Just so code, so you can see it's working, and the presentation you can sort of see it visually, right? So all right. So in this step, right? So right again, you will see, there's a PDF to Parquet, right? Module. So this is the module that's going to run and extract text from PDF. And you can see, we are just setting it up like input port, output port, the usual stuff, right? And I'm only telling you to say only process PDF files. Because remember, you can process PDFs, HTML, right? Other file. In this case, I'm only interested in using PDF. That's it, right? And then basically, right, we are just launching our program. And you can see, right, it's doing this to download a bunch of, bunch of models, remember, right? Because it's using a deep learning model to process PDF. It's downloading the models on the fly, and it's yeah, it's done. Right? And if you look at the output, you can see, right, each document becomes a row. So the way the toolkit does that is like, it's gonna create some one row per document. Right, master PDF, also PDF. You can see the contents are here, like in JSON format, right? And also you have some metadata, like how many pages the document has. 1 page, right? No tables found, right? It also create things like right, hash of the document, right, and things like that. Pretty good, right? So what I've done from my 2 PDFs, I've extracted the content. The contents are basically in this content column. Yeah. Now let's see what this looks like. And I'm going to just print this out just so I sort of have an idea, right? So you look at that, I'm just simply printing it out, right? And if you look at the data, you can see, right? See how it says, right? You can see this is the actual raw JSON from the PDF, right? So you can see, right? It has, you can say things like, what's the file name, right? Like metadata, how many pages, right? All that. Did we find any pictures? Did we find any tables? And what's the text data look like, right? And then the text data, you can see things like, section header, right? Mask, right? And then you can sort of start seeing like, right, the heading, solar system, here's a paragraph, right? So you can kind of start seeing it's extracting the structure of the PDF. The text data is what you want, right? So the text data, right, is the extracted text. Again, I'm showing you a little like under the hoods, just so you understand what's going on. I mean, if you're using it, right, you don't need to like, do all this debug print. So think of it like a debug print to see, like, what's going to happen, right? Because I kind of like to, when I'm using something new, I want to understand what it's doing. So, so that's why I wrote this to say, okay, let me see how the PDF is being processed. And you see it now, right? So that's it. Pretty good, right? So you're going to keep moving, right? Again, like I said, it's just, printing out JSON, right? So I'm just printing out the contents. You can see JSON. So let's just scroll down a bit. So let's go to step 4. So step 4, I'm going to create chunks. Okay, let me show you what this involves. So we're going to split the PDF into chunks. Now, why do you want to do this? Right? Because when we do queries of PDFs, it's much more efficient to query the relevant segments. Right? Because let's say I have a 100-page PDF. I know maybe my answer in like only the first 2 pages. There's no need to search all 100 pages, right? You want to search only the 11 chunks. That's what we are doing here. So split into chunks, so you can see, right? The first paragraph becomes a chunk. Next paragraph becomes a chunk. You can see here, right? Next chunk. There are different chunking mechanisms, right? And again, for example, some people like to chunk per page, right? Some people like to do per paragraph, which we are kind of doing right here. You can configure this, right? Chunking is important because chunking will determine your search results. So if your chunks are too big, right, or too small, right, that has impact on the search. So at this point, I always get a question like, what is the right chunking size? Honestly, there's no right or wrong answer. There are a few methods, right? Like I said, page-wise, paragraph-wise, things like this. Try them out. and then see which one gives a better result for your documents, right? Because remember, if you look at some benchmark, right, how it performs on somebody else's document doesn't matter to me, right? What I care about is how it works on my documents. And the way to find that out is just try a few things. And these are very easy. Right? There's like a simple parameter you can tweak. You can say, all right, yeah, try page-wise, try paragraph-wise, right? Do a search and kind of see how it all works out. Right? Easy. So, okay, so how do we do chunking, right? So again, chunking is a module that's built in. Let me show you here. So let's come and go back to the code. That's what we are doing here in step 4. Okay. So again, 4.1, I'm just saying I'm setting up where's the input. Remember, it's actually resuming, right? So kind of remember the workflow. Remember the workflow. So we just extracted text from the PDF documents. That extracted text is the input to the next stage. So the chunking section is going to grab the text, then create the chunks. All right. All right. So let's see how it looks like. Just scroll down. Right. So I'm all right. So that's why I'm setting the. So my previous output is my input now. Remember, we are going in stages. I think like a pipeline. And then right there's a chunk document chunk module, right? And then basically I'm running this. So yeah, goes through. Right. Chunking is done. Let's look at what the output looks like. Remember, I have two PDFs, right? Earth and Mars. Let's see what the chunking looks like. So I'm putting out the output. So now you see, right? I see multiple entries for Earth and Mars. Right? Why is that? Remember, each file is created multiple chunks. So for example, Mars, right? Mars PDF has how many chunks? 1, 2, 3, 4, 5, right? 5 chunks. The third PDF also has chunks, right? And you can look at the table, which file name it came from, right? And the actual contents. Let me move this a little bit over here so you can see it. All right. Let's see the content, right? This is a chunk. So basically, we are doing paragraphs, right? Interesting. So don't be alarmed, right? When you start, it's like I start with 2 documents, right? At this point, I have, let me see, 11 chunks, right? My input is 2 documents, output is 11 chunks. That's fine, right? Each document splits into different chunks, right? So, very good, right? So that's the next step. So now I have split the document into chunks. Again, so I'm printing out a few things here, right? You can see it, right? Again, we can see, right? So here's a chunk, right? In the master PDF, my first chunk is the first paragraph, second paragraph, right? And the bullet points. See what I mean, right? By the way, this last chunk, if you're wondering what this is the footer, the page number. So page number 1, right? So there's an option to skip header and footer if you want, right? By default, it's processing header and footer. So yeah, there's an option to turn off that parameter. You can specify that. But right now, I'm picking it up. Yeah. But yeah, don't worry. There's a flag you can specify to not ignore the header and footer. So anyway, so you can see just now we have plain text from our documents. Interesting, right? So step 5 is called document ID. So what this is creating hashes for the chunks we just created. Why do we need this? Remember, we are going to perform deduplication, right? We're going to eliminate deduplicate, right, chunks, right? And also do a fuzzy dedupe. And in order for us to do this, we need to create hash for right? whatever content we want to eliminate. Because comparing hash is much quicker than comparing the actual text, because the text could be pretty large, but the hash is pretty well defined, right? So that's why we're creating hash. So step 5, honestly, right, is pretty standard, right? Right. Again, if you look at this, you see the same process, setting up input/output folders, right? Running, there's a doc ID module. We are running this, right? I'm saying compute the hash in the contents column, right? And the output, I'm saying, right, create in this column. Let me show you, right? Let me show you the output, right? So if you look at the output here, let me move to the right a little bit so you can see. See, I see a couple of new columns. The hash just calculate. Okay. Why are we calculating hash? Because this is what we are going to use to remove duplicates. So every transformation you do, it keeps adding more columns to the data, right? So in this case, right, you can see I calculate the hash for the chunks. Yeah. All right. All right. Step 6. So this is interesting. We're going to actually perform deduplication. So let me first explain what this looks like. Now, if you look at our document, right, again, at this point, I'm just eliminating dedupe at a paragraph level just so we understand it. You can do the exact same thing on a document level too, right? So I'm keeping it simple here. I'm just eliminating paragraphs, like the similar paragraphs. But imagine you can do the same thing for the entire documents, right? So if you look at the first paragraph, you can see it's exactly the same text, right? So I'm going to eliminate one of them, right? Because it's duplicate data. Yeah. So how do we do this? Very simple. You'll see this here, right? In the code, and again, 6.1 setting up input output, right? Visual, right? So I have an exact dedupe module. I'm running it, right? And I'm saying, look at the hash we just computed. Remember the hash we just computed? Chunk hash, right? I say compare this hash when you try to figure out duplicates. So you can configure this to anything you guys like, right? So let's say you're calculating your own hash, for example. You can give it that. The algorithm is very simple. If you have multiple entries with the same hash, it's going to eliminate one. Right? So that's it. Right, all of this you can specify. So I'm running this here. I'm launching it. I'm running it, and you can see right after run, I'm printing out. Right, again, you can sort of see here. There you go. I start with 11 chunks, right? So input chunks before dedupe is 11. After dedupe is 9. So we remove 2 chunks. Interesting, right? There are 2 exact duplicates. We eliminate. Now imagine if you have documents. Let's say you are let's say you have 10,000 documents. Out of the 10,000, say 1,000 are duplicates. You run this, right? You eliminate 1,000. You're left with say 9,000. Pretty good, right? So again, you can see we are computing the hash and then comparing the hash to eliminate duplicates. Very straightforward. Yeah. Yeah. So, all right, guys. And again, here I'm just printing out. So you can kind of see this right on here. But again, like I said, this is more of a debug output. I'm doing this just so you understand what's going on. Because remember, when you're using a new toolkit that's dealing with data, I want to understand what it's doing, right? Because data is very important. We don't want some toolkit, doing the wrong thing. So the reason I wrote this notebook is so I understand how it's processing and I understand the toolkit's features. So hopefully you find it useful too, right? So we're just printing it out. You can see, right? So you can see there, right? In the master PDF, the right one of the paragraphs was eliminated. Remember the comment paragraph we had? Where was this? Right? Right? Our solar system is vast and fascinating expanse, right? This is basically eliminated from mass. You can see it, right? See. Earth, on the other hand, has it. Right? So this is a duplicate that's eliminated from here. Interesting, right? So exact deduplication, pretty good, right? Okay. The next one is fuzzy dedupe. So let me explain what it will do, right? So when you do fuzzy dedupe, remember, fuzzy dedupe catches documents that are almost the same, right? Because exact dedupe will catch documents that are exactly the same. I mean, documents are identical. They have the same hash. But as we saw, there could be some documents that are near duplicates that has different hash. So the fuzzy doodle will actually do this for you. So the way I'm illustrating this is like, right? For example, look at the second paragraph, right? They're pretty similar. Only word is like one word different, our solar system and the solar system. Right? So I say, you know what, we are going to eliminate this. Yeah. Now, fuzzy doodle will catch that, right? So if you look at this, right, after you run fuzzy doodle, one of them will be eliminated. So now in this case, in our case, excuse me, I just turned off the fuzzy dedupe because the fuzzy dedupe um, sometimes has issues running on Colab, right? Because Colab gives you limited resources, and fuzzy dedupe creates a lot of what we call a lot of workers to compare documents, and sometimes they will run successfully, sometimes it won't. Now, if you're running it locally, fuzzy dedupe will work just fine, right? So just if you look at the code, you will see right there, I have a code here that actually does fuzzy dedupe. You can look at this here. Let me see if I can bring this up. Right. So same thing, right? If you look at this here at step 7, there you go, right? So you see the code for fuzzy dedupe, right? I just turned it off here because I was running into some issues in the Colab. In fuzzy dedupe, you can see, right? They create, right? Remember, it's a multi-threaded program, so they use, right? You can specify things like how many workers to create and everything to run your fuzzy dedupe. Yeah. And also, fuzzy dedupe has this parameter called threshold. I want to explain this a little bit. So remember, fuzzy dedupe is not exact science, right? How do you make sure the documents are close to each other, right? So there's like a knob you can tweak to see how strict or how lenient you want your fuzzy dedupe to be. So if you make it too strict, then it won't, right? Then it'll look for very strict matches. If you sort of dial it down and make it a little lenient, then it can catch more, more duplicates. Now again, what's the right setting? The setting is from 0 to 1. 1 meaning very strict, 0 meaning very lax, right? So you want to kind of find a value somewhere there that works for your documents. Right? So again, people ask me all the time, like, what's a recommended value? So the default value is 0.8, right? Which is okay, but for this example, 0.8 didn't catch anything. So I kind of dialed it down a little bit, made it 0.7. Then actually it was able to eliminate that duplicate paragraph. Remember the one I just showed you, right? There was that, right? This paragraph, there's only one word different, right? Our solar system, the solar system, right? So when I dial it down to 0.7, let's able to eliminate this. Yeah. So again, just play around with the setting a little bit, see which one works for you guys. This is a very powerful feature, by the way, fuzzy dedupe, right? Because it can actually help you eliminate a lot of similar documents. Like I was running this experiment, had a bunch of documents. So we had PDFs, right, which are like almost the same. There was like a new line at the end, right? So if we do like a simple document comparison, they are like different documents because the hash is going to be different, right? Hash is very sensitive to data. So even if like one character is different, your hash is different. So if you just compare the hash, you're not going to catch the duplicate. But if you do fuzzy dedupe, it will catch it, right? Because it will say, okay, yeah, these hashes, right, they are very similar. Only like there's just a bunch of new lines. That doesn't really add any value, so it'll eliminate it. So this is actually a pretty cool feature. All right, let me see questions. So one of the question is in PDF, kind of paraphrasing this a little bit. Can we extract like paragraphs and subtitles? Yes, actually here it will do it for you. This tool, let me go back here. Right. So when we actually extract data from PDF, you will see it keeps the structure. So it'll say, okay, this is the header, right? So, it'll tag them for you, right? So when they extract the content from PDF, they know what kind of content it is. See, so it's not like just plain text, right? It actually keep the structure. They will say, okay, this is the section. This is the paragraph. This is the list, right? So the extract is pretty smart. It will actually keep this for you. So take a look at the, so the question you're asking is, I mean, you don't have to do this manually. You can control this if you want. But like you can say, let's say you have like headings, subheadings. You can say things like only do like level 3 headings. Don't go beyond level 3 heading, right? Things like that. You know what I mean? Like when you do process PDFs, right? You can do this. Just like a spec file, you can specify. You can say, here's my PDF. Do H1, H2, and H3. Ignore the smaller headings. You can do that. Yeah. But honestly, most of the time, I didn't have to mess around with this too much because, by default, it's doing a pretty good job. So I didn't have to bother. But yeah, it has options. And also you can do things like ignore tables. You can do things like, don't do OCR, right? Or you can say ignore header and footer, or consider them, right? Whatever, right? So there are a lot of options you can do when you do this PDF processing. So take a look, right? So if you look at the documentation, they will show you. Yeah, good question. All right. All right, so where are we in our path? Just gonna reset everybody here, right? So okay, so we extracted the text, we split them into chunks, right? So 2 documents becomes a bunch of chunks, and then we create a hash of this chunk just so we can eliminate duplicates. So we did the dedupe. So with the dedupe, you can see, right? I had 2 B's, one of the B's eliminated, right? But I still have near duplicate A and A dash, right? 1 and 3. You see this, right? When I run through fuzzy dedupe, one of the A is eliminated. So now I have clean set of documents. What we call clean chunks, right? ABC. Duplicates are gone, right? Everything is good. The final step is we're going to actually vectorize this. Okay, let me show you what the vectorizing is, right? So these are called embeddings. So embeddings are pretty cool because if you want to do search text, you create embeddings first. So basically, like let's say I have a word apple, when you create an embedding, right? Just gives you a bunch of numbers. Banana, different set of numbers, right? So it may seem like, sure, right? I'm converting text data into numbers. That's fine, right? But what's happening is when they create these numbers, these are called vectors, by the way, because these are multidimensional numbers, right? Think like an array of numbers, a vector, right? We plot them into a graph, right? So when you map these words into numbers, they will actually put them in places that actually have meanings. For example, let's say I started mapping a cat, right? So let's say it maps here. Let's say this is a 2-dimensional vector, right? In the x and y axis, right? Just 2 dimensions, just so we can visualize. So the cat vector mapped here, right? Let's say I'm mapping next is banana. So banana has nothing to do with cat. So it kind of maps away from cat, right? Then I'm mapping dog. So the model is smart enough to know dog and cat up, right? When it reads the documents, right, it says, oh, you know what? A lot of the time, cats and dogs are mentioned close to each other. So to map the dog close to the cat. So it's not going to map the dog next to a banana, right? Because most of the time, if you read text, right, you won't find dogs and bananas in the same sentence. Maybe. I mean, not that much, right? you guys know what I mean. So a lot of the time, dogs and cats are mentioned in the same sentence, the same vicinity. So that's why dog and cat are mapped close to each other. Let's say next what I'm mapping, say apple. So naturally, right? So right, the model will say, okay, where do apples are mentioned? Apples are usually mentioned in the fruit category, right? So it's going to map them next to the fruit. So as it's doing the mapping, so it's kind of using the intelligence it read, like because it may not understand what apple is, but it knows apple and banana are mentioned pretty frequently together. Cat and dog are mentioned frequently together. So that's why it's putting them together. Right? So it's kind of like like imagine you're reading, let's say you're reading a Japanese newspaper, right? Let's say you can understand the words, but you don't know what they mean. You can read the actual word, right? But you don't know what that means. So imagine you're reading a lot of Japanese newspapers, right? You kind of start recognizing, okay, hey, these 2 words kind of happen together. Right? I mean, you don't know what they are, right? I don't know, what these words actually mean. I just see, these words are happening close to each other, right? And that's exactly what the model is doing, right? As it's trained on a lot of text data, it figures out, where these, mappings need to happen. But the good news is these mappings actually have value, right? Because, right, for example, so now you see natural groups are forming, right? These are fruits. This is like pets, right? So let's say now I'm mapping, doing a query for pineapple, right? I'm mapping pineapple. So most likely pineapple is going to map in the fruit section, right? So it's probably not going to map to, the pets, right? It's going to map to close to fruit section. So let's say I'm doing a search for pineapple. I'll get the, pineapple and the relevant fruits. Pretty cool, right? So I mean, this you can actually try today. Like if you use like Google Maps, Apple Maps, whatever. Go to your Maps application and do a search for, let's say, I don't know, like donut, right? So sometimes you get donut shops, right? At the same results, you will also get results like ice cream shops, right? And you're wondering, I search for donut, why is it showing me ice cream shops? Because remember, right? So if you search for donut, ice cream, they can assume, okay, if you're searching for donut, you are looking for a dessert, maybe. So maybe we'll show you ice cream shops. So that's what for relevant search, right? If you search for donut, most likely you're not going to find a ramen restaurant listed. Okay? Remember, donut and ramen, right? They don't go together. Right? So this is what we mean by vector search, meaning semantic search, right? Not just exact keyword matching, but also context of your search. Is that going to make sense, guys? Right? Anyway, so when you create an embedding, you can do some smart searches like this. Pretty cool, right? And that's the last step for us. So we are going to do a search on this text data, and we need to create embeddings for each text. So when the text are basically chunks, right? What we are going to do, right? For each chunk, we are going to create a vector. And the module is already created, right? So we're going to actually use the code, right? There's my code, yeah, right? So final step, text encoding, right? By the way, I'm doing this embedding model. What's embedding model I'm using? It's set up somewhere here. Yeah. So I'm using this particular embedding model. It's an open source embedding model. There are a lot of open source embedding models you can use. For example, right? That's what I'm showing you here, right? Right. I'm using the sentence transformer mini LLM, right? And remember, these embedding models, there are many, and some of them are proprietary, some of them are open source, right? You can, right? The open source ones are good and pretty good as well. So let me show you real quick. Like there's like a leaderboard here. If you click on this link, it'll take you to the embedding model leaderboard. So what they do is they benchmark these embedding models and give them a score. Right? It will take a while to load. So let me show you. There you go. Right. So and you can see, who's the top performing model. So the top performing model right now, rank 1, is NV Embed V2, right? And it's a pretty big model. It's like that's 7 billion parameters. Right? To use it, you need 30 gig memory. So it's a pretty massive model. Now you can see, and its score is 72. Right? Again, let's look at the average score. Think like a benchmark, right? Like a test benchmark. So it's scoring 72% the overall test. Okay, that's a pretty decent, right? Score. And you can go down, and you can sort of, as it go down, the score keeps declining. All right. So the large models tend to do well, but they are also expensive to run. And you can see, right? I mean, as you can see, right, as it's going to go down the right, model sizes get smaller and smaller. And let me look at my screenshot here. Oops. There we go. Right. So I took the screenshot a few months ago. You can see my ranking are different than what you see there. Remember, the ranking is changing on a daily basis. So by the time I took the screenshot, the highest model is Mistral, 66, right? And you can see it's a 15 gig model, 7 billion parameters, right? And so on and so forth. And if you go down the list, you can see the next model down, right, is scoring 64 instead of 66, storing 64. So you lose 2 points. But look at the model size though. It's like 10 times less, right? So maybe it's maybe a little easier to run. So I chose a model that's pretty small, it's scoring like 56. Right? I can remember this is a demo, right? So I just wanted something quick, fast to run, and this is scoring 56. Not that right? I'm down 10 points the score, but you can see it's a much smaller model. Interesting, right? You see that, right? And then yeah, so which one to use? Up to you guys, right? You can choose a large model to run, but remember, a large model takes a lot of CPU and GPU to run. They'll give you good results, right? But if you can achieve the same thing with a smaller model, why not? Yeah? So that's what I was showing you guys. So here in the last section, right? If you look at the right, we're running. There's a oops, let me go to the last tab. There you go. There's a text encoder module. I'm running it. So all it's going to do is going to basically, right? It's downloading the model at runtime. It's very good. It's going to create an embedding column. If you look at this, you'll see at the end. See, now we embeddings. What are embeddings? Just a bunch of numbers. We know what they are, right? Anyway, so now you can sort of see, right, the whole pipeline. Right? So what we actually set out to do, right here, start the PDF, extracting data, chunks, dedupes, and then final step is vectorizing. And now we can actually query our data. So why are we vectorizing? So we can query the data efficiently, right? That's it. Yeah. So does that kind of make sense? So this is the whole workflow, right? Again, the code is designed to run on Colab. You're going to run it, right? Hopefully you're able to run it and see the results. Can I see a quick thumbs up if you guys are able to complete, like, your notebook completed running and you sort of see the results? Yeah, give me like a thumbs up if you're able to see the output. Yeah, very good, very good. Thank you. Yeah, and remember, you can also run them on your local laptop as well, right? If you want to run on your local laptop, make sure to follow the getting ready instructions and set up your local environment. Right? So I cannot. I like to do it in Colab just so you can run it without having to do any extra setup, and you can see it works really well. Right? All right, guys. So what we have done, right? We looked at sort of section 1 here, right? Understanding how data prep kit can help you with your data, right? Data preparation tasks or cleanup tasks, right? I went through a couple of presentations. The links are here. And also we ran the code on Colab. Yeah. Any questions? Go ahead. I have a couple of questions I will get to. Question is, what is Ray? So I talked about Ray, right? So Ray, let me show you. So Ray is actually a Python framework. So Ray takes your code. Let me show you this here. Right. So Ray will take your Python code and will distribute them, run them on multiple machines. So you want this, right? If you have lots of documents, right, you cannot process them on a single computer, right? Because it doesn't scale. So what you can do is Ray is a framework that will take your Python code and run them on multiple machines, like a distributed computing, right? So the data prep toolkit actually supports Ray out of the box, right? So that's why, right, if you look at our code, I have like a local version that runs on your local laptop. The same code will run on a Ray cluster, right? We have a Ray version. So one only thing different is going to be, right? I'll just show you real quick, just so you're interested. So see, when I'm running this, right? So I'm running a Python launcher, right? If you look at the Ray version, exact same code, you will run Ray launcher. That's it. Only difference, the launcher is different. That's it, right? Everything else is the same. Pretty good, right? Anyway, so yeah, so you can start on your laptop, right? Start working on it, and then once you want to scale, change a couple of lines of code, then you can run and distribute it. Pretty good, right? So good, guys. Any other question? Let me see. Good. All right. So one more time, let me put these links here for you guys. So this is what you want to take a picture of, or, right? Bookmark the URL. Workshop is here, right? It will bring you to the GitHub page. And this one has all the resources you need, how to set up your environment, right? And also all the slides that you used in the presentation and everything, right? So, and also, there's like so we're only doing this section on this workshop today. If you're curious, I have another workshop here, like it's called RAG, right? If you're playing with RAG pipelines, give this a try, right? We are ready to run code. If you are looking at submitting, say, PDFs to RAG or something, right? So we have code on that too. Yeah. Cool, guys. So that's it for today. I want to make sure everybody good. Any questions so far? Please go ahead. All right, guys. So thanks so much for being in the workshop. I'm going to give you some time, right, so you can kind of play around, experiment. If you have any questions, right, please, right, shoot me a link, shoot me an email. My email is here. I'd love to hear from you. And again, thank you so much for being in the workshop. Yeah. All right. Thank you, guys.
Thank you for speaking today and for giving us your time. Everybody, if you have not joined the Discord channel, we have lots of conversations being continued in the Discord channel. So I encourage everybody to jump over there, continue talking with the community. Suji, you're welcome to go over there. And I believe you shared, yep. Suji did drop his presentation in the resources. So if you want to come back to that, you can absolutely do that. And I think we don't have any other questions or anything. I think you covered everything, right?
Yeah. We went through. There's some good questions. We covered them. So again, thank you guys for being in the workshop, asking questions. I really appreciate it. Hope you're fine. Hope you're enjoying the conference. We will see you in the workshop. Thank you.
Thank you, everybody. Thank you, Suji.
Thanks, Omara. Thank you.